Now geologists had a new mystery to solve, discovering why the Colorado River took the path it did some 5.5 million years ago, and why it carved a canyon of such remarkable dimensions. The investigation into the history of the Grand Canyon has uncovered a 1.7 billion year old landscape that has evolved from ancient mountains through to the Colorado Plateau. 5.5 million years ago, the Colorado River began carving out the Grand Canyon from this plateau. The question scientists now had to answer was what happened at that time to cause the river to dig deep and carve out the canyon. It is a debate that has been going on for more than a century and which continues today.
I got interested in the Grand Canyon when I went to school and started studying, and I heard about the different ideas associated with the Grand Canyon and was just blown away when I found out we did not understand how the Grand Canyon formed. Something as iconic as the Grand Canyon wasn't understood, just seemed crazy to me, and so basically decided to dedicate a large portion of my life to trying to figure it out.
One theory is that several ancient rivers merged and their combined cutting power started digging out the canyon. Another assumes that the river cut down into the plateau as the land uplifted around it. But John Douglas has his own theory, one that has gained respect among many leading geologists since he first published his ideas in 2000. What Douglas calls his spillover theory seems to work well on paper.
Spillover is incredibly easy. All it means is the Colorado River poured into a basin. When it poured into that basin, it had to form a lake. And this lake was huge. All that lake had to do was rise and then spill across the plateau. It poured down, cutting rapidly, and over time you would have ended up with the beginnings of Grand Canyon very quickly.
At his college campus in Phoenix, Douglas is building a scale model experiment to see if his spillover theory actually works in real life. He sculpts tons of dirt into a model of the Colorado Plateau. Running faucets represent the flow of the Colorado River into the ancient lake.
Now we have our large lake. The water's getting higher, it's getting ready to spill across. We have a tiny little trickle of water pouring down off the lake. That little tiny trickle of water doesn't seem like much, but over time, that little bit of water flowing down that steep slope is going to gain energy. It's going to start cutting, making waterfalls that work their way back. One waterfall has now reached the lake. You can see that we have just released a significant amount of water, much more water than was previously pouring down. Now we have huge canyon cutting. Landslides are sloughing off the side of the canyon walls, the water flushing it downstream. The lake, you can see that it's starting to shrink in size. That lake is getting lower. And right there, you can see that we have cut our own small-scale version of the Grand Canyon.
Douglas's experiment proves that the spillover theory works in miniature. But he needs evidence to show that it could have happened on an infinitely bigger scale. Douglas sets out in search of a lake, large enough and old enough to be the source of his spillover flood. He has a prime suspect in mind. This is the site of the ancient Lake Bittahoche, 100 miles to the east of the Grand Canyon. And a clue here on the old lake bed reveals how deep this lake once was.
These green clays, which indicate deep lake water, this is the classic evidence for the giant lake necessary for the overflow explanation of Grand Canyon.
These green deposits are only created in one specific environment.
To have green lake clays, you need deeper water where there is little oxidation. I think that's indication that the Colorado River has arrived in this basin, that it's made its way from the Rocky Mountains to this location. And this is its basically stopover point before it eventually spills across to form the Grand Canyon.
Establishing the depth at this point lets Douglas work out how large an area was once covered by water. He compares the depth of the water with the contour height lines of the surrounding countryside. And that shows that Lake Bitahoche once spread over 20,000 square miles and contained more than 3,000 cubic miles of water. That makes it bigger than Lake Michigan. Douglas needs to date the age of this lake. For his spillover theory to work, it has to be older than the Grand Canyon, more than 5.5 million years. He unearths the proof he needs in these deep water fossils.
Okay, these fossil shells are freshwater mollusks, maybe as young as 6 million years old.
The dates match up. The lake was here at the right time to have spilled over and begun cutting the Grand Canyon. Dating the fossils helped confirm Douglas's belief, but his search for more evidence continues.
In reality, we're never going to know how it formed to 100% certainty unless someone builds a time machine. By doing this kind of work, all you're trying to do is increase your level of confidence on your ideas, build up your case, build up your evidence.
Building up his evidence is exactly what Joel Pedersen is doing. He is using the very latest technology to prove exactly how fast the Grand Canyon was carved. He has found the evidence he needs right here, at the very start of the Grand Canyon.
Here at Lee's Ferry, there are all of these gravels that are evidence of where the river has been in the past and the path it has taken during incision. And amongst the gravels, sometimes you see these great lenses of sand, and we can use the sand to get an absolute date on these deposits.
As the Colorado River carved out the canyon, it deposited more and more of the gravel and sand debris at this spot. Newer layers buried older layers over millions of years. And geologists now have instruments that can measure how light has affected individual atoms within the sand. That reveals precisely when each sand layer was originally buried, away from the light of the sun. For the technique to be accurate, it's essential that the sample is not exposed to daylight.
So here we can take a metal tube and we can hammer it into the sand outcrop, and in the metal tube then we'll get a sample of the sand and it'll stay out of sunlight, and then we take it back to a darkroom laboratory and remove the sand still sheltered from light, and then we can analyze the optical properties of it to get an absolute age. And in this case, the absolute age would tell us when the river was at this point in the landscape.
Back at the lab, Pedersen compares multiple sand samples, each from a different depth in the canyon deposits. Discovering the age of each individual layer of sand lets him estimate how rapidly the river has been cutting down through the rocks.
Here at Lee's Ferry, we can use this last 500,000 year history along with our absolute dates and all the information we get. And the rate of canyon cutting here is about 1,000 feet per million years.
That's 1 foot in every 1,000 years, a little more than 1 inch every century. It proves that the entire 5,300-foot deep Grand Canyon could have been cut in a little more than 5 million years. In geological terms, the mere blink of an eye. The investigation is assembling evidence on how the Grand Canyon was created. Green clay deposits support the theory that an ancient lake was big enough to spill over and trigger the canyon's creation. Deep water fossils prove that the lake existed 6 million years ago, the right time to have overflowed and cut the Grand Canyon. But proving how the canyon cutting began is only part of the investigation. This is one of the widest and deepest canyons in the entire world. And to discover how it grew so large, geologists will have to examine some of the most dramatic and dangerous features the canyon has to offer.